Okay, we're going to look at solving systems of equations using substitution. Substitution just means that you're going to take one value and substitute it in place of another value. In our first example, we have y equals negative 8x minus 17 and y equals 3x plus 5. Now, both equations are in the form of y equals. So if negative 8x minus 17 is equal to y, and 3x plus 5 is equal to y, then that means that they have to be equal to each other. So I'm going to write negative 8x minus 17 is equal to 3x plus 5. We're taking this negative 8x minus 17 and we're substituting it in place of the y. Now I'm going to subtract 3x from both sides. And I have negative 11x minus 17 equals positive 5. Then I'm going to add 17 to both sides. And I'm trying to isolate my x. And I get negative 11x equals 22. Then I divide by negative 11. And I get x equals 22 divided by negative 11 is negative 2. So now I know that my x is equal to negative 2. We have two different choices of equations that we can use to find the value of y. If I use the first equation, y equals negative 8x minus 17, I'm going to substitute 2 in place of my x. So y equals negative 8 times negative 2 minus 17. Negative 8 times a negative 2 is 16 minus 17. 16 minus 17 is negative 1. So, in our solution, our x is equal to negative 2, our y is equal to negative 1. We write that as an ordered pair, negative 2, negative 1. If we were graphing this, that is the point where these two equations would intersect. Now I'm going to take the second one just to make sure that it works, or just to show you it doesn't matter where we go. And I'm going to take x equals negative 2, and I'm going to substitute it in place of x in the second equation. 3 times a negative 2 is a negative 6. Negative 6 plus 5 is equal to a negative 1. And we got the same value for both of our y's. So that means what we did was correct. So the solution for this system is negative 2, negative 1. Okay, in example 2. This time, instead of both equations being set equal or solved for y, we only have one equation that's solved for y. So this says that y is equal to negative 2x plus 7. So what that means is I can take this negative 2x plus 7 and I can substitute it in right here in place of the y. So what that's going to look like is 8x minus 4 times negative 2x plus 7 equals 4. So now we're going to have to use our distributive property. This is a negative 4. A negative 4 times a negative 2 is going to be a positive 8x. A negative 4 times a positive 7 is going to be negative 28 equals 4. We're going to combine our like terms. 8x plus 8x is 16x minus 28 equals 4. I'm going to add 4. No, not add 4. I'm going to add 28 to both sides because I'm trying to isolate my x. That gives me 16x equals 32. Divide by 16. And we're going to get x equals 2. If you're using a calculator, you're going to put 32 divided by 16 in the calculator, and you get x equals 2. All right, now I'm going to take this x equals 2, and I'm going to go back to this first equation, and I'm going to put 2 in the place of x. So y equals negative 2 times 2 plus 7, because it was negative 2x plus 7. So the 2 took the place of the x. So that's y equals negative 4 plus 7. Y equals 3. So So my x is 2, my y is 3. Therefore, my solution is 2, 3. So these lines will intersect at point 2, 3. Okay, for example 3, we have two equations. We have 5x plus y equals 21, and we have 2x minus y equals 0. So what's happened here is we don't have an equation that's already solved for y. You can take the first one and subtract 5x, and you're going to get y equals 21 subtract 5x. Okay? Now, this y here is understood to have a coefficient of 1. So now, we're going to take this 21 minus 5x, and since y is equal to 21 minus 5x, we're going to put it here in place of the y. So I'm going to write 2x minus 1y equals 0. Replace the y with the 21 minus 5x equals 0. Use my distributive property, 2x minus 21. Negative 1 times 21 is negative 21. Negative 1 times negative 5x is a positive 5x equals 0. Combine my like terms. 2x plus 5x is 7x minus 21 equals 0. We're going to add 21 to both sides. That's going to give me 7x equals 21. And then we're going to divide both sides by 7. And 21 divided by 7, x equals 3. All right, so now that we know that x is equal to 3, we're going to take this x equals 3, and we're going to substitute it in right here so that we can find the value of y. So y equals 21 minus 5 times 3. So instead of writing x, I'm putting a 3 in place of that x. Y equals 21 minus 15. 21 minus 15, y is equal to 6. Your solution set, or your solution for this system is going to be 3, 6. Okay, on example number 4, we have two equations again. I have negative 4x minus 8y equals negative 20. The second equation is x plus 5y equals 23. So when you look at these equations, we don't have one where we have a variable that's isolated. When we look at this first equation, the x has a coefficient and the y has a coefficient. In the second equation, the x does not have a coefficient, but the y does. So what we're going to do is we're going to solve for x. So I'm going to subtract 5y from both sides, and that gives me x equals negative 5y plus 23. Or you can write this as 23 minus 5y. So now that I know that this is what my x is equal to, I'm going to take this expression and I'm going to substitute it here in place of the x. So now when I rewrite this equation, instead of putting x, I'm going to put negative 5y plus 23. So I have negative 4 times negative 5y plus 23 minus 8y equals negative 20. Use your distributive property. You get 20y minus a negative 4 times 23 is negative 92 minus 8y equals negative 20. Combine like terms. 20 minus 8y is going to give you 12y minus 92 equals negative 20. We're going to add 92 to both sides. You're going to get 12y equals a positive 72. Divide by 12, and we get y is equal to 6. So now, I know that my y is equal to 6. I'm going to take this 6 and substitute it here to get the value of x. So x equals negative 5 times 6 plus 23. So x equals negative 30 plus 23. X equals negative 7. Therefore, your solution set, your solution for this system, put your x first, will be negative 7 and 6. Okay, on example 5, we have the same situation. We have 4x plus y equals 6, and we have 2x minus y equals negative 9. We can start with this first equation and solve for y. And that gives me y equals negative 4x plus 6, or you can write 6 minus 4x. This y in the second equation is understood to have a coefficient of 1. So now I'm going to take the negative 4x plus 6 and substitute it in place of the y, and that's going to give me 2x minus 1 times negative 4x plus 6 equals negative 9. Use your distributive property. 2x plus 4x minus 6 equals negative 9. 6x minus 6 equals negative 9. Add 6 to both sides. I get 6x equals a negative 3. Then I'm going to divide by 6. We have a fraction. We're going to reduce it. X equals a negative 1/2. So now I'm going to take this negative 1/2, take it here, and put it in place of the x. And we're going to have y equals negative 4 times a negative 1/2 plus 6. And we know when you're multiplying two negatives, you're going to get a positive. And half of 4 is 2 plus 6. And 2 plus 6 is 8. Your solution for this system would be negative 1/2 and 8. With a solution like this is an example of a problem that we couldn't solve using graphing because we got a fraction for our x value. So this problem supports the reason why we have to learn a different method.